The idea of machine learning is how do you get machines to learn from data? And so you look at patterns in the data, and the machine and the various algorithms look at patterns and learn those patterns. Sometimes I feel that there are lots of people talking about AI who don't necessarily engage with it and don't deeply understand it. And so sometimes the conversations are often either incomplete or incorrect. And so my hope was, how do we present AI? And in particular, I'm focusing on making decisions through AI. They're making so many choices for us, mostly in ways that allow us to be productive. And, instead of taking hours looking through information, Google says, here, these are the 3-4 websites you could focus your attention on. And that's what we all do. And it's very productive and helpful. But the flip side, of course, is that, you mentioned agency earlier, the extent to which we are fully in control of our decisions, it's not quite what it used to be. The algorithms are nudging us in different ways.
Hello, everyone. Welcome to the Bounce Podcast. I'm Larry Weeks. My guest on this episode is Kartik Hosanagar. Kartik is a Johns Howard Professor of Technology and Business and a Professor of Marketing at the Wharton School of the University of Pennsylvania. He's been recognized as one of the world's top 40 business professors under 40, is a 10-time recipient of the MBA or Undergraduate Teaching Excellent Awards at the Wharton School, and his research has received several Best Paper Awards. Kartik also co-founded and developed the core IP for Yodel, which is acquired by Web.com, and he serves on the advisory boards of Milo and Monetate, Milo being acquired by eBay, and is involved with many other startups as either an investor or a board member. And he has a new book called A Human's Guide to Machine Intelligence, How Algorithms Are Shaping Our Lives. It's about algorithmic and AI decision-making, and it's the topic of our show today. Algorithms are embedded in the technology you and I use, and they make a huge number of everyday decisions for us, like the products we buy, the directions we take. Algorithms curate and serve up our news. It matches people on dates. Even life and death decisions are delegated to algorithms, once made solely by the domain experts like a doctor or pilot. And Kartik makes the case that we need to arm ourselves with a true understanding of algorithmic thinking. I really enjoyed this interview. Kartik is obviously very smart, but he does a masterful job not only explaining algorithms and AI, but also illuminating how it impacts our everyday lives and specifically what we can do about it either personally or collectively as a society. It's also a great overview of the evolution of artificial intelligence. So you can kind of see where it came from, how it started, and understand how important it is as to where it's going. And you need very little technical knowledge to enjoy this episode, in my opinion. In fact, the less you know technically, the more it would behoove you to listen to it. It's a look into the brain, if you will, of all of your devices, at least the software that's running them. And if you're curious at all as to all the buzz about artificial intelligence, Kartik provides this great kind of history lesson. There's also a great retelling of how AlphaGo beat the world's best Go player, human player. I wonder how long it will take till that human annotation is always necessary. So we talk about a lot of things like an overview of algorithms using kind of the recipe metaphor. We talk about an appreciation for what they're doing for us, how they do that, and how they're making our lives better, why it matters, and the risks associated with outsourcing our decisions to them without thought. We talk about the issues with bad data and data brokers, the evolution of AI, some of the early efforts in the 50s, the target being human-level intelligence, and then the shift to rules-based systems and automating functions, and the ensuing renaissance in machine learning. We talk about understanding AI by understanding human nature, the black box problem, when we cannot know why a machine takes a particular action, which leads into AI safety and interpretability, and then the predictability resilience paradox. And then we kind of wrap it up with his view on the future and how we can prepare for it. I think you'll really like this episode. So without further ado, here's Kartik. Kartik, thank you so much for coming on the show. Appreciate it.
My pleasure, Larry. Thanks for having me.
Your book is really, to me, this is my perspective, really balanced it gives technology an even hand. You're like, you're just kind of laying out a couple of things. One is just an even, hey, here's technology, it's kind of neutral. But hey, it could go this way or that way. And then you back up though, and the book is really about algorithms and kind of the evolution of AI.
Oh, thank you very much. Thanks for those kind words. And I did feel like, there's no dearth of books and discussions on AI and so on, but I always felt that either it comes from a place of hype or a place of intense skepticism and almost fear. And I felt that there wasn't often a nuance that I would have liked in here. And also because it's such a hot topic in business, sometimes I feel that there are lots of people talking about AI who don't necessarily engage with it and don't deeply understand it. And so sometimes the conversations are often either incomplete or incorrect. And so my hope was, how do we um present AI? And in particular, I'm focusing on making decisions through AI. So that's the algorithmic decision making piece. And really talk about what does this mean for us, and also not talk about what it will mean for us 100 years from now, which is again an interesting conversation to have. But I think sometimes we forget that it's actually there around us right now and it's impacting us now. And so I wanted to talk about what it's doing today and what it'll do 5 years from now, 10 years from now, within our immediate or near term future, so that it's more real and tangible for the readers.
And I think you succeeded because my audience is a mix. I have some very savvy listeners, and then I have some people that are not so tech savvy. So your book is perfect in that regard. So for the audience, let's define algorithms. I like your analogy of the omelet.
Yeah. So that's actually a good place to start. Algorithms, we hear the term a lot. I think people have a rough sense of what it is, even non technical people, but it's actually not a very complex idea. Algorithms are quite simply a series of steps one follows to get something done. So if, I have a set of steps I follow when I make an omelet. Step number one, I put some, let's say, butter in there. Step two, I beat the eggs in a certain way and I add salt in and so on. And that's the set of steps I follow. You could call it an omelet recipe, but the computer scientist in me calls it an omelet algorithm. And pretty much any software application we use today, it's following a set of steps in order to accomplish the task. For example, when you go to Amazon, you're ready to buy a product, you see a message, people who bought this also bought this. So that is essentially an algorithm that says, let me look at this item that this user is looking at. Now let me find everybody else who's bought that item. Next, I'm going to ask what else have they bought. Then I'm going to come up with a count of all those items, how frequently they were bought, and then recommend the most popular item. That's a set of steps that Amazon's recommendation software is following. That is the recommendation algorithm. And that's true for any software you use. There's a set of steps you follow. That's the algorithm. And of course, those algorithms have evolved over time and have become more intelligent. And I'm sure we'll talk more about that evolution.
Yeah, I was thinking how someone could really get a good idea, which obviously you explained it well, but I have TTT, this application with applets that you could go in and create if this, then that kind of rules. It's overly simplistic, but it is kind of this recipe of telling a machine to, if something happens, trigger an action, what have you. So people could actually go on there and play with that application and kind of get an idea of a very, very basic kind of rules-based algorithm. So the other is, and you go through this in the book, but I think people understand they're using maps, they're getting directions. If they request an Uber, all of these applications have some kind of algorithm that's directing the cars and the locations and the whole nine yards. And what's great about starting with algorithms is it's in our lives now. And that's kind of to your point to your book, we're defaulting and offloading a lot of some of these onerous tasks like opening a map, unfolding a map, and trying to figure out where I am.
So they're all around, our lives. They really pervade a lot of our lives. And in some cases, it's obvious, and in some cases, it's less so. So I'm sure most of your listeners are used to, of course, things like Amazon's recommendations and or on Netflix where shows are recommended to us. And in fact, my research shows that they have a very significant impact on our choices. On Amazon, over a third of our choices are driven by algorithmic recommendations. On Netflix, over 80% of what we view is driven by algorithmic recommendations. If you look today at how dating is happening, you have apps like Tinder that are driving dating recommendations, and in fact, almost all the matches on apps like Tinder and Match.com are algorithmically determined. They're at the workplace, whether recruiter is using an algorithm to shortlist thousands of job applicants into the few that are worth looking at or inviting for the job interview. Bankers are using it to determine whether to approve a mortgage applications. They're also making life and death decisions. So, in courtrooms in the US, judges are asked to consult algorithms that will predict risk scores, such as the likelihood that the defendant will reoffend. And that is used to drive bail, parole, and sentencing decisions. Medicine is moving in the direction of precision and personalized medicine. And the idea there is algorithms, again, will look at individual DNA information and then suggest what is the right treatment for this person. So, in some ways, they couldn't be any more important because they're actually all around us and they're making so many choices for us, mostly in ways that allow us to be productive. And, instead of taking hours looking through information, Google says, here, these are the 3, 4 websites you could focus your attention on. And that's what we all do. And it's very productive and helpful. But the flip side, of course, is that, you mentioned agency earlier. The extent to which we are fully in control of our decisions, it's not quite what it used to be. The algorithms are nudging us in different ways.
Yeah, and can we just park for a second and just acknowledge, I think we lose some of the appreciation of what algorithms and some of these systems are doing for us. There's probably businesses that obviously wouldn't exist today without some of these platforms. But I was thinking about Maps the other day, and that how many small businesses people never knew about because there wasn't a places listing. Maps is doing more than just directing people to help someone get from A to B. They also are opening up opportunities for a coffee shop that maybe you wouldn't have discovered. And there's just a lot in our lives. And you mentioned a lot of them: medically, diagnostics, and then shipping and routing and airplane reservations, analysis, data analysis, drug design, hell, entertainment, computer gaming.
Yeah.
So, there's a lot that has kind of brought on a little golden age of some of this automation. I get the risks, but I just wanted to say algorithms, these are good things.
These are great things.
Yes, yeah. Yes. I think we tend to, we'll yell at Siri and
Yeah, I'm sure each of us has some frustrating experience, and sometimes that becomes salient, whether it's with Maps or with Siri or with Amazon's recommendations or what have you. But I think when it works well, we don't notice it as much. And so, but the fact is, mostly it works super well.
Have you read this story about the medical park, the Fruit Belt?
No.
There was a community that disappeared from Google Maps and basically made this city like it wasn't there. And then people would assume it was, I think, called Medical Park, and they thought it was going to be this new community. And the older residents living there, or the people who lived there many years, were very offended that people were treating this as a transitory place when it had been there forever. So Google Maps, it just didn't show. And in fact, it labeled everything Medical Park. And then people thought they were going to build condos. And so people were driving through the neighborhoods. It was just, it was scary. They were like, and they didn't know how, the residents didn't know how to fix the issue. It was like, well, who do we talk? They talked to the county. It wasn't, their maps are okay. And they couldn't get a hold of anybody in the maze of Google support as to what was going on. They finally, I think everybody through all these audits, that it was data coming from Pitney Bowes, where Google was just using all this legacy data. It really wasn't maps. It was this old company had done these surveys. But that's one example of the risk, I think, kind of similar to what you pose, that, if you've got some bad data in the coding hierarchies, you're going to have about bad output. So, although algorithms are great, this is how they can go wrong.
Yeah. I mean, there's many examples over the last few years. Each person may have a different favorite, but yeah, there have been many. Of course, one that got a lot of attention was Facebook's newsfeed algorithm, and the idea there was that they had human editors curating the trending news stories on the newsfeed, and they were these human editors were accused of having a left-leaning bias, and so Facebook said, you can't accuse an algorithm of having a bias, so they replaced all the human editors with an algorithmic editor. And of course, as we all know now, this algorithm was not able to detect fake news stories, at least back around the 2016 elections, and so that was the problem with that algorithm. There was another example where ProPublica came out with this investigation of algorithms used in courtrooms in the US, the ones like the kind I mentioned earlier that predict recidivism scores or likelihood that this defendant will reoffend. And their analysis showed that the algorithm had a race bias. And so in that case, the algorithm was twice as likely to falsely predict future criminality in a black defendant than a white defendant. And in fact, late last year, there was a different story of Amazon trying to use resume screening algorithms because, hey, Amazon gets, I don't know, maybe 1 million job applications. They had 100,000 people last year, so lots of job applications. You can't have human recruiters sift through that many resumes. And so they tried to use algorithms to sort of automate that process. And it turns out Amazon's own analysis showed that these algorithms had a gender bias. And they, of course, denied this algorithm access to the gender of the applicant, but it figured out other ways to infer the applicant's gender. And they tried many things, but they couldn't get rid of the gender bias. Of course, Amazon detected it and therefore did not roll out the algorithm. But Amazon is a very savvy tech company, and it's great they detected it. But there's many companies looking and using such algorithms, and you bet many of them have these gender biases. And these are just a few examples. There's many other examples in various settings where algorithms have what I call unintended or unanticipated consequences. They're meant to fix one thing. Sometimes they do that well, but there's something else that we didn't expect would happen that did happen.
I'm assuming there was some machine learning with the Amazon resume. If it wasn't a rules-based algorithm, I'm assuming it was some kind of machine learning to make those inferences, right?
Right. So Amazon's algorithm was a machine learning algorithm. And for listeners who aren't familiar with it, the idea of machine learning is how do you get machines to learn from data? And so you look at patterns in the data, and the machine and the various algorithms look at patterns and learn those patterns. So in Amazon's case, the idea might have been, here are all the people who applied for jobs in the past. Here are the people who got invited for job interviews. Here are the people who got the job offers. And here are the people who got promoted. Now find people who are likely to be successful at Amazon, meaning people who are likely to get job offers and likely to get promoted at Amazon. And so if an organization has certain biases, we have all subconscious biases. And so if those exist, then the algorithm tends to pick those up because it's looking for patterns in the data and trying to imbibe that. And in this case, it looked and observed that men were more likely to get promoted, and it tended to heavily favor men over women. And so that's one example. And it was machine learning. And of course, you hide the person's gender, but then there's other ways for it to infer the person's gender, like the name of the person.
But this is where the challenge comes from, right? If it's a basic rules-based algorithm, it's either doing the calculation or doing the computation and outputting the result that you want or not. But as machines become more complex, and this is where I think the meat of your thesis and the book is, it starts making decisions on its own based on this machine learning and these neural networks, just like humans learn. And the way you told and wrote about the story of Go, and is it DeepMind?
So maybe it might be helpful if I read a very small passage from the book, and then I'm going to set some context on that passage. And so I'm obviously not going to read the whole section, but I'm going to just read a small paragraph or a brief couple of paragraphs that talk about this game between AlphaGo, which is Google's Go playing software, and Lee Sedol, who is the world champion at Go. And Go is particularly interesting because unlike a game like chess, which is highly complex, both these games, chess and Go are highly complex. But with chess, with brute force computational power, you can just explore every possible move that you could take and ask what will the other player do and look at all their moves and so on, and kind of figure out how will the game play out if I played my move and the other person plays their best move and so on. But Go, there are just too many possibilities, and so you can't use brute force computational power. So you need something more creative. And so I'm going to read this passage over here. After a resounding defeat in game one, Sidol was playing more carefully, and even though AlphaGo had gained a slight early edge, the contest was still anyone's to win. Then move 37 happened. AlphaGo, playing black, made an unusual move on the center right of the board. I thought it was a mistake, said one commentator within seconds of the play. Seedall stepped out of the room briefly and took nearly 15 minutes to respond. Fan Hui, a European Go champion who had previously lost to AlphaGo, remarked, "It's not a human move. I've never seen a human play this move." He later described it as so beautiful, so beautiful. AlphaGo went on to win this game.
When he said that wasn't a human move, that gave me chills just for a second. When I read, I'm like, I get that, because it's using deep learning and because it's making these connections that aren't programmed because of the nature of machine learning. They didn't know why it made the move, right?
Yeah, the people who created the program couldn't explain the move, and that's what's so interesting about it. And to help explain that, I'm going to back up a bit and talk about how algorithms have evolved over the years. Now, it used to be the case 20 years back when I, for example, did my engineering undergraduate studies. When we designed algorithms, it was mostly engineered end to end, meaning that a human programmer identified every single step the algorithm would take. So that's the rules-based approach that you mentioned earlier, right? We would identify rule. If this happens, then the algorithm does this. If that happens, then you do this, and so on. And it's a series of if-then kind of statements. And that was the old way of designing algorithms. And it works reasonably well. If you look at a complex task, like let's say you want to diagnose diseases, you could interview doctors and interview them for hours and identify the set of rules they follow, and you create a system that follows those rules and that can diagnose diseases from based on patient symptoms. Again, such algorithms work reasonably well, but it turns out they're often no match to a human expert, because we all have a lot of tacit knowledge that we cannot express as rules. And this notion of tacit knowledge comes from this Hungarian mathematician called Polanyi. And it's a pretty important idea that there's a lot of knowledge that we have that cannot be articulated. For example, if I were to ask you, Larry, here's a photograph of 100 people, can you recognize your mom in there? You, of course, can do it. But if I say, give me the rules so that I can recognize your mom, you can give me a lot of different rules and I can apply the rules, but my software, which uses those rules, will not be able to recognize your mom because there's a lot of tacit knowledge that you're not able to express as rules. So to overcome this limitation that we cannot identify all the rules we use in decision making, we have lately gone in the direction of machine learning, which is the idea of let's give the machine a lot of data and let it figure out patterns. So if you want to diagnose diseases, we say, here's data of 1 million patients who walked into various hospitals. We have the actual symptoms they had, all the tests reports, and we know the final diagnosis by the doctor. Now figure out the patterns. So nobody is giving the machine any rules. It observes the pattern and it says that, okay, if this person has a fever over a week, then I rule out the common cold, I rule out perhaps viral infections, and I explore bacterial causes or things like that. I'm making this up, but the point is it observes those patterns and it learns the rules. But that's where machine learning is today. And one of the implications of going from rule-based system to machine learning-based system, I call it the predictability resilience paradox, which is that if you use rule-based systems, these are highly predictable systems because we came up with those rules and we know exactly what it will do when it encounters a certain condition because we coded those rules in. So highly predictable, but it's not very resilient because the moment it encounters a new situation that is not programmed in, it doesn't know what to do. And so it kind of fails. So it cannot really address all kinds of situations. It's hard to have a driverless car that is completely, a human putting in the rules in there. It's very hard to build that. In contrast, you have a machine learning system, you give it videos of thousands or millions of people driving, and it observes and learns the patterns. And so it's highly resilient because it's seen lots of different edge cases, weird cases, and it knows how to respond to that as long as you give it lots of data. But it's a bit more unpredictable because when you give it that much data, such data cannot be curated. You can't have a human being look through the data and say, okay, this is clean data. I'm going to give the clean data. That portion is not clean.
Or a tiered hierarchy of decision making because there's so much data, it would take you forever. Yeah.
It would take us forever, exactly. And so you can't curate that data. And so we don't know what's in the data. We know mostly the data is, it works. But maybe there's a weird thing that happened in the data and the driver was kind of on the phone and got distracted and did something weird, and the machine might pick that up. Or humans have subconscious biases, and maybe we have gender biases, race biases when we evaluate resumes, and it picks it up. And so that happens. But I think the other interesting thing in the evolution of this is we are going now to or we will go over the years towards a new kind of machine learning, which is called reinforcement learning. And the idea there is not even to feed the machine data, but the machine generates its own data, meaning the machine tries new things and observes what happens and learns from that, usually in settings where it's simulated or not costly. So in fact, Google came up with a new version of AlphaGo called AlphaZero, which is zero stands for zero training data. So it was not given any data on how people have played. So AlphaZero just plays millions or billions of games against itself and observes what happens in those games, and it learns, what's a good way of playing, what's a poor way of playing. But the implication of it generating its own data is it's playing the game in ways humans haven't played in the past. It tries something super strange, and no human will ever consider it. But then, maybe out of those billion cases, 999 million, and pretty much every one of those cases except one might be really poor strategies. But one of those cases where it tries something crazy and it works out, it learns a new move, a non-human move that works, but no humans tried it. And so for us, it's like, whoa.
It's really cool. It's exciting, but it is eerie. So I didn't know about the Facebook bots that talk to each other. So I want to push people to the book because there's a story about these Facebook bots that were talking to each other, and they created their own language. It reminded me of all these sci-fi movies where the computers start connecting and you know what I mean? So I get excited because of the possible solutions we're going to have that we don't have today, right? That's exciting. Yeah. It's like, what do we not understand about economics that is limited? I'm just using it as one example.
Yeah.
On the other hand, right, is all the doomsday scenarios as to it goes in a direction that may be detrimental to society or people or genders or what have you. So it really leads into, I think, the challenges you pose that we have as to policy explainability, like you said, the resilience and the paradox of if we make these systems so narrow and just rules-based, they're going to be limited in use.
Yeah.
But if we make them more powerful and open them up, they're able to do more for us. But also, we understand them less because they can fork here and there. But let me just back up because this is where you led in Early in the book, you go to the history of algorithms and AI. By the way, machine learning is made up of multiple algorithms. The neural network is basically nodes of these hundreds of algorithms that are each kind of feeding into them. So it was really cool how you presented the history. Like in the early efforts in the 50s was actually AGI, or artificial general intelligence. They were shooting in the 50s for human level intelligent applications, right?
Yeah, so when the field started, and it's not a very old field, it's just early 1950s when the field got started with Alan Turing coming up with a paper where he posed this question, can machines think? And it really led to interest in this question of, can machines be more than just glorified calculators? Can they actually think? And led to the start of this field called artificial intelligence. And initially, people had these big goals, and the goal was what is today referred to as strong AI or artificial general intelligence, which is essentially human like intelligence. And the idea is that it can think like humans and it can solve like humans. And if you think about what is intelligence, it includes things like, understanding language. It includes things like navigating the visual world. It includes holding and manipulating objects, reasoning, learning, and all of that stuff. They wanted to do all of that at once. And it proved to be too hard. And mostly it resulted in a situation where, they promised a lot and underdelivered. And so it created an AI winter. And then slowly the field started going towards more practical, achievable kind of targets and goals. And it succeeded now in large part to do what we call today as artificial narrow intelligence or weak AI, which is the idea that you have a system that's intelligent at a task, but it's not generally intelligent, meaning that AlphaGo can play Go amazingly well, maybe better than a human, but AlphaGo cannot converse with you, and AlphaGo cannot drive a car. Or you have a driverless car that's able to drive a car as well as humans, but it cannot play Go or cannot play chess, and things like that. But now I think now that artificial narrow intelligence is working, now there is an interest in the community, and researchers are asking, okay, what does it take for us to now go towards the artificial general intelligence goal, where we have a system that's intelligent like human beings, not at a task, but across tasks, but has more computational power and therefore can process more data and can therefore learn faster than humans. And that would be fascinating.
Yeah, and you compared human behavior and psychology with kind of machine behavior and kind of machine intelligence. There is some comparisons there, right? With where we're headed with AI and machine learning.
Absolutely. I think there are some legitimate comparisons with human behavior. And one of the insights I had as I was trying to figure out how do I explain AI behavior to a layperson was that as I was trying to explain in different ways, eventually I said, okay, think of it in terms of human behavior. And it struck me actually the similarities are more than I had expected before. So with human behavior, psychologists bring down our behavior to our nature and nurture, right? And we've all heard the nature nurture analogy, nature being our genetics, what we inherit from our parents, and nurture being our environment, what we learn from our friends and people around us. And so psychologists will look at something like, let's say, alcoholism, and will attribute, a certain portion of it to be because of genetics and certain portion of it to be because of nurture. And so many problematic behaviors are attributed, and people can say there's, it has a basis in nature and has a basis in nurture. Now, if you look at algorithm behavior, I've realized that it has nature and nurture as well. And the nature for an algorithm is not its genetic code, but it's the code that the engineer or the programmer gives it. It's the logic or the rules given by the engineer. And so that governs its behavior and sets the limits to the set of behaviors in some ways. And then there is nurture as well. And nurture is the data from which algorithms learn. And so it used to be the case that algorithms were almost all nature, very little nurture 20 years back, meaning the engineer gave all the rules, those if then statements that we talked about. If this, then you do this, and so on. But increasingly, we're kind of saying, okay, they can learn a lot from data, so let's just give it data, and the actual code is maybe just 50, 100 lines of code. And almost all the intelligence the algorithm has is in the data. And so now it's increasingly nurture, very little nature. And so the data is starting to matter a lot. And in fact, I like to, jokingly say that if our algorithms are behaving badly, then they're kind of hanging out with the wrong data, right? To reinforce that analogy.
So it also made me think that we can almost understand more about ourselves as we try to understand or create some type of general intelligence in machines.
The related thought is something that my group does spend some time looking at, is looking at our attitudes towards algorithms, and in particular, why we decide to trust some algorithms and not trust some other algorithms, or why one person might trust an algorithm and another person might be more skeptical of that same algorithm. And so we have done, and this is not just me, some of my colleagues and other researchers have also done some work on looking at what drives trust. And it's really interesting. There's many things, and I don't think we have enough time to cover all of them, but I'll mention a couple. One of those interesting findings is that people are initially highly inclined to trust algorithms, and people tend to think of them as objective, rational decision-making engines. However, when people observe an algorithm fail, the way they react to an algorithm is very different than the way they react to human failure. And in particular, people are more forgiving of human failure and and not as forgiving of algorithmic failures.
Is that an empathy type behavior, or why is that?
I think maybe it has to do with the fact that we're kind of thinking of them as objective, rational decision makers, and so
they shouldn't
are starting off with this expectation that, hey, this has got to be better, and then when it doesn't deliver, you're very disappointed, and then you kind of say, this doesn't make sense. I won't use it. And so one of the interesting implications for that is, I think when companies roll out algorithms, they need to not just ask, is it better than the alternative being human decision making, but it's got to be much better in order to win people's trust. So when you have something like happen, like let's say the Tesla autopilot crash or the Uber self-driving car accident, I think it does erode trust quite dramatically. And in fact, there was one survey I remember that was conducted before the Tesla autopilot crash, and that same survey conducted after the Tesla autopilot crash, trust in autonomous vehicles was much lower. And so that was one example of that. So it does say that, look, I think we need to be, from a trust and affect and people's perception standpoint, I think we need to not rush in rolling out new technology. You can't have the Silicon Valley old kind of mindset, which is, fail fast and early and just keep rolling it out. And we learn with that. I think with some of these, at least in socially consequential settings, I think we have to be a little more careful. That was one. The other one I'll mention is that transparency seemed to have a lot of impact on algorithm trust. And many studies have shown this, but transparency is all about, what do I know about how the decision is being made? And if we go towards these deep learning algorithms or, the reinforcement learning, where I was saying the algorithm creates its own data and learns from it, it might be hard for engineers to provide an explanation and say, these are the rules driving the algorithm. And so if you don't have transparency, then it can affect user trust. And so we have to also work hard, and there is ongoing research in academia on how to make some of these black box algorithms more interpretable, but that becomes more important.
And that's also a big part of your book, talking about the black box problem. Why did the machine do what it did? And the ability to audit what went wrong, or audit the code or the program. And the point is, the more complex, the more neural networks and the more sophisticated the machine is, the harder it is to figure out why the machine did what it did. There's some movements afoot to create either policies right around that or before they're implemented, or at least maybe possible policies in the future for it. And your algorithmic Bill of Rights, I think, in the book proposes some of that. But let's talk about that. I talked to someone who has a program software that's kind of driven by AI, and he has a term called AI theater, where his program kind of ran in the background and did what it's supposed to do with the software and propose the solutions or whatever. But he had clients come to him, customers, and saying, we want to cancel. I don't think this is doing anything. And not until he exposed either a progress or what the outcome was or how the program came to the decisions and how much time it either saved or what it calculated. When he exposed that to the user and they could see, they all felt satisfied with the product. And there's not only a benefit from a standpoint of, as you say, why did it do that for error resolution or, postmortems or what have you, but also from a value add. So if these things are utilities running in the background, you do think nothing's going on, right? Yeah. But there may be some value in, as I said, this AI theater concept.
Yeah, absolutely. I think, we recognize that algorithms have value. They drive a lot of decisions, but we also are seeing they can go wrong. And the question is, what checks and balances do we need in place? And as I was thinking about those checks and balances, I proposed what I call an algorithmic Bill of Rights in my book. And it's essentially a set of basic principles or checks and balances that I think consumers can and should expect, especially when algorithms are deployed in socially consequential settings, like, let's say, recruiting or credit approval or news curation and so on. And so in thinking about what are these checks and balances in place, two of the pillars in my algorithmic Bill of Rights relate to transparency. One is transparency. Actually, before I talk about those pillars, transparency, sometimes the algorithms are making our decisions and we don't even know an algorithm made a decision. Like, your mortgage application was rejected, but we don't know.
That's a good point. That's a good point.
Yeah, it's good to, first of all, just say an algorithm made the decision. And then the question is, what kinds of data does the algorithm use? And then secondly, what are the most important variables for the algorithm? Some basic logic and some basic information about data. So sometimes you might apply for a loan or you might apply for a job interview, and the company is looking at your social media posts or things you might not even have shared or given them explicit consent to using. And so transparency with data is trying to address that. And transparency with regard to what variables are feeding into the model is just about knowing at a high level what's driving the decision, and knowing that behind the black box, at least there's been some tests and audits and something to confirm that it's not doing crazy things like having a gender bias or looking at gender and race and then making decisions based on that. So transparency helps win trust and also just make sure some basic checks have been done to address that.
Do you think this is going to come from the government top down or?
Yeah, so it's really interesting. In Europe, they pushed GDPR, which is their data privacy legislation. And within GDPR, they have a few checks and balances, including one that is a right to explanation. So when algorithmic decisions are made, consumers have a right to explanation, which is along the lines of what I'm saying is transparency. And there it came with the government push. I feel that is certainly an option, but also when you have a government push like that, you also have a risk that sometimes it might go too far, right? So in fact, there have been some criticisms of GDPR as being too burdensome to companies. And one way to avoid that is when companies become proactive and consumers become proactive. And when consumers say, hey, we expect certain set of things, and companies say, we'll do this on our own, some basic set of things, which helps avoid heavy regulation. And so I think there are all of these possibilities. I do feel that algorithms have an important enough impact that we do need some government oversight. And I've suggested in the book that there could be an oversight agency, like an algorithmic safety board, and that only focuses on certain socially critical settings and not all kinds of algorithms, and whose role might be to share best. By the way, Singapore government does this very industry friendly approach where they share best practices with the industry, but then they have no actual power to legislate or regulate. And GDPR is at the other extreme where it's fines and it's like 4% of your global revenues and it's very heavy. I think there's a middle ground where you kind of say, we'll share best practices, we'll provide oversight, we'll take complaints. And through this, we know in general what's happening, but we're not going to say, very heavy legislation that you are required to do this, you're required to do that. But that's one way to do that. But I think companies should do this on their own. Otherwise, you risk. We're already seeing some consumers and even presidential candidates talk about very heavy regulation against companies, which I think would be a huge problem to the industry.
They need to get in front of it. The companies need to get
in front of it, absolutely,
or lead it. But also brings to mind, elections are coming around. We need smart people in government who understand, or at least know who to go to and bring in to think about these things, right? I mean, this is the future is going to be more and more complex on its own, but add in the use of algorithms via AI and wow, we need smart people out there that can get this. And speaking of the Bill of Rights, algorithms are good things, and we need to evolve with it. We need to oversee it, and we need to apply human rules. We don't want to be passive when it comes to our lives. We want to be curious, take responsibility, exercise agency.
I think my message would be that algorithms can add amazing amount of value to our personal and professional lives, and while they have, while there are tremendous possibilities, we also know, based on what we've seen so far, based on our knowledge of how they work, that they can be a bit unpredictable and that they can do things we don't expect them to do. And we can no longer use technology as passively as we've been doing so far. We need to be a little more deliberate about how we use technology and help it make decisions for us or about us. And so being deliberate involves not, again, needing to understand the nitty-gritties of the algorithm, but at a high level understanding, what is going on here? How is it changing decisions I'm making or others are making about us? What checks and balances are in place? What are we expecting from our companies? What are we expecting from the government? Are we holding them accountable? Because I think if we don't do that, we lose agency. We lose agency at an individual decision-making level, but also as citizens, where decisions will be made for us or about us in ways that we just won't have control. And so I think now is the time for us to ask for certain checks and balances and put those in place.
Do you think an introduction to computer programming should be like a basic from school?
I think so. Yeah, absolutely. People ask, what can I do as an individual? I think at the end of the day, as an individual, the power we have is the education, our dollars and our votes. We talked about votes, right? Which is electing people who are savvy and understand the nuances here. Dollars is, again, comes from education, which is, we need to, vote with our wallet. And the education piece is very important. We're very passive with how we use these systems. They're so deeply entrenched in our lives. And I think we need to be more educated. And one way for that to happen is it's got to be part of, for example, schooling. And so one potential solution is you could say, hey, programming is needed for everyone. That is a broader mandate, I feel, which is not just about, this issue we're talking about, but it's also about the impact that computer science and programming is having in jobs everywhere, and the fact that it allows you to bring genuine skills to whatever job you have going forward. But I think even if you don't know programming, having some algorithm literacy is important. Having some basic literacy of the kinds of things we talked about. How are these algorithms built. What's the difference between a rule-based system and a machine learning system? What is machine learning? How does it actually learn from data? Those kinds of things. That basic literacy, I think we need to have, and it needs to be in schools.
Yeah. Be curious. Why, when I ask Google a question, did it spit out this answer, right? Why is the maps taking me back roads versus the highway? Just start asking questions about the results you get. I mean, sometimes if I learn a route on maps, I'll turn it off once I've kind of figured the route. I'll just check it for traffic, but just so that I still have some orientation skills, that I have some agency. Although I use maps all the time.
Yeah, I once spoke to somebody at a bank, and he said, "Well, I enter all the applicants' information, for loan applications, into the system, and it spits out, score and says, approve or don't approve." But he wasn't able to tell me, what does the algorithm look for. And so it was interesting that you're finally giving a decision, but you don't know what that decision is based on. And
I didn't know that.
Yeah. So sometimes I think we're all using these systems in our personal lives or at the workplace, and we use it very, very passively.
So what is your view of the future with AI, let's say careers and jobs? Or do you think this is going to be a net positive? What is your prognostication?
Yeah, so overall, I'm actually optimistic. I think, it could be a net positive. I think we will have many growing pains along the way, and we have to put those checks and balances now so that we don't experience these problems along the way. We will experience many, there's no doubt for me. But I think it'll be a net positive. Having said that, where does this take us 200, 300, 500 years from now? I have no clue. I'm not a futurist. I don't even believe we can predict, our futures that far ahead. And so it's really hard to say. But, I can at least say, I've looked at how it's been trending over the last, say, 20, 30 years and where it began 50 years back. And I can project that out over the next 20, 30 years. And I think we will have many growing pains. And so that's why I feel we need these checks and balances. That's why I've advocated for that in the book. But at net, I'm not an algorithm skeptic. And I sometimes, when I hear some people try and instill fear with the word algorithm, that worries me. And I think that's not the message here. The message is, look, there's so much value. One analogy I use is in the book is, well, if caveman or whichever early man who discovered fire had run away from fire because it could be dangerous, well, we wouldn't be here. You wouldn't have had industrial revolution. You wouldn't have had many things. But yes, fire can be dangerous, but we've put lots of checks and balances. Occasionally it still goes wrong, but those checks and balances help ensure mostly it doesn't. And so I think maybe that's the way to view this. This is a tool that's of great value, but we'll periodically have issues. The more checks and balances we have in place, the fewer and less impactful those problems will be.
Yeah, because the advent of the internet and mobile and bandwidth, it's so new. It's changing so fast that we're learning how to behave with it and deal with it. And your book is going to go a long way to help. And I think your book should be required reading for the layman just trying to figure out, what is going on in my environment and the technology that I'm using. So it was also interesting. You founded Yodel, right?
Yeah.
Is there any cool systems now, bid platforms that you think are up and coming?
I would say that world is quite mature now. And there are, most of the companies have similar capabilities, at least as they advertise in terms of how it works. I haven't used these in a while recently, so I can't say who's better than whom.
And Google's doing it in AdWords.
And Google's doing it, exactly. And Google's making so much of this available to advertisers directly that for many of them, they don't even need a third-party company or third-party solution because Google's gotten better at suggesting what's the right keyword for you, by analyzing your website and your traffic patterns, but suggesting what you should bid.
And they're doing it at the auction level, which is, your third party can't get there.
Exactly. The one catch is Google has a potential conflict of interest, right? Because the money you pay goes to Google. And so that's why still many companies kind of say, well, these are great tools, but I'd still prefer someone who's representing me rather than Google that's saying use this, but then Google keeps the money. But I think some of the interesting things that are going on is people are using machine learning in creative design, which is a newer area. So if you look at the actual ad copies, when I built Yodel, we could automate keyword identification, we could automate bidding, but the actual creative, we had an account manager kind of come up with the creative, whether it's a text creative on Google or some of these more visual creatives on other websites. There's a lot of automation going on in that space. And I think that's a pretty interesting thing. And they can automate the process of experimenting with multiple creatives, come up with 20 designs, quickly test them out, see which one's winning, and select the winner, and then maybe even try variants of that, and very fast converge to a winning creative design. I think that's the more interesting thing that I'm seeing in that space lately.
Yeah, there's also website builders that are saying or touting that they have some type of either machine learning or AI that will optimize the site for you. Or
yeah, there's much of that going on, but also sometimes when companies we have AI, we have machine learning, they're mostly...
It's regression analysis or something.
Exactly. It's some basic technique and they're hiding behind the AI term to make them look sophisticated.
Kartik, this was great. Thank you so much. And the book again is, I really loved it. I recommend everybody go out. Where can they can find you? You have your website, right?
Yeah, so my website is my last name, so Hosanagar, Hosanagar, www.hosanagar.com. My book is A Human's Guide to Machine Intelligence. They can find me on Twitter. They can find me on LinkedIn. Yeah, I'm easy to find.
Okay, thank you so much again. This was great.
Thanks for having me, Larry. I enjoyed the conversation.
Well, that is all the time we have today. Please spread the word if you enjoyed the episode. Leave us a review on iTunes and share it with your friends on your favorite social platforms. Big thank you to Sam Williams, my audio guy. Make sure you visit LarryWeeks.com for all my content, and we will talk again soon.